Hey everyone. So what we're going to look at today is we're going to continue on this conversation around solving systems, but we're going to begin looking at it from an algebraic stance. Okay, so just as a recap, what have we dealt with already? Well, we've dealt with building systems. So we have to start with a legend, and then we have to come up with two equations and two unknowns. We've talked about the fact that the solution is the value for x and y, or for whatever our variables are, the values that work in both of those equations at the same time. We then went into solving by graphing, and we realized that the values that work in both of those equations at the same time is in fact the intersection point of the two lines. And so we spent one lesson graphing by hand and understanding that, and then we spent one lesson graphing by graphing technology and understanding that. Okay, so now in these last two lessons, we're still solving, we're still trying to find that point, but we're going to do it from an algebraic approach. So today is on substitution, and then tomorrow, the next lesson will be on elimination. Okay, now to start us off, what I'd like to do is I'm going to read you a little word problem that I want you to try on your own, okay? And here it is. So I'll read it, and then you can pause me. It says the problem is to figure out who won the third round of tug of war. Here's what you know. In round one, on one side there are 4 acrobats, each of equal strength. On the other side are 5 grandmas, each of equal strength. The result is dead even. Dead even means it's a tie. Nobody won, nobody lost, okay? Okay, in round 2, I've got Ivan the dog, and Ivan's pitted against 2 of the grandmas and 1 acrobat. Again, it's a draw. That means nobody won. Equal weight on both sides, or equal strength, I should say, on both sides. Okay, so round 3, this is what you're going to figure out. Ivan and 3 of the grandmas are on one side, and 4 acrobats are on the other. And the question is, who's going to win? So pause me, play with it a little bit. Okay, welcome back. And so I'm going to walk you through a solution to this. And really my point with the solution is not really the answer, but I want to kind of establish this visual for you of what it's like to do substitution. Okay, so humor me as we go through this for just a couple minutes. This is what I know, okay? I wrote down everything I know. I know that I've got 4 acrobats in round 1 with 5 grandmas, and I knew that it was a tie. So that tells me that the weight of 4 acrobats is the exact same as the weight or the strength of 5 grandmas, okay? Then in round 2, I had Ivan the dog, and he was pitted against 2 grandmas and an acrobat, and that was also a tie. So I know that the strength of Ivan equals the strength of 2 grandmas and an acrobat. Now, up here in the left corner is what I've got for what I'm trying to figure out. This is round 3. So I've got 3 grandmas and an acrobat, and sorry, 3 grandmas and Ivan, and then I've got 4 acrobats. So I'm looking at all this information and I'm saying, okay, what do I know? Well, come back down here for a second. I know that 4 acrobats is the same as 5 grandmas. That means anytime I see 4 acrobats, I could substitute those 4 acrobats with 5 grandmas because they're the exact same. So I'm going to make a substitution. I'm going to say, okay, those 4 acrobats are just like having 5 grandmas. Okay, then I'm going to look at Ivan. I got Ivan right here, but I know from this round here that Ivan is the same as 2 grandmas and an acrobat, which means anytime I see Ivan, I could replace Ivan or substitute Ivan with 2 grandmas and an acrobat. Well, now when I make those substitutions, I see that on the left side here, I've got 5 grandmas and an acrobat, and on the right side, I've got 5 grandmas. So 5 grandmas and the acrobat are gonna win that round. There's more strength on the left side, but it's not 5 grandmas and an acrobat, and it's not 5 grandmas. I have to substitute back and put what it was originally. So I know that this side wins, but I need to put it back to the way it was. And now I can conclude that the side that has 3 grandmas and an acrobat is going to win over the side that has, sorry, 3 grandmas and I said an acrobat, sorry, 3 grandmas and Ivan. The side that has 3 grandmas and Ivan is going to win over the side that has 4 acrobats, okay? Now, substitution is just all about that. That's what we're going to do today. It's just that instead of talking about grandmas and Ivan and acrobats, we're going to talk about X's and Y's, okay? But the process is very, very similar. So far, we have solved the system graphically. Now we must develop an algebraic method for solving systems. There are two that we'll look at today is called substitution, and like I said, tomorrow we'll do something called elimination. Now, we'll start though with what you know. I want you to solve this graphically, just as a quick review, okay? So in order to solve graphically, we're going to write these as y equals. So for the first guy, I need to bring that 4x over, so that'll be y equals negative 4x plus 7. I can graph that. I just go up to 7 on my y-axis. And then from there, I'll go down 4 over 1, down 4 over 1, and I'll get that line, okay? The next guy, I need to bring my 3x over to the other side, so that'll be 2y equals negative 3x minus 1. And now I need y all by itself, so I'll divide everything by 2, and that will give me y equals negative 3 over 2x minus a half. So that means my y-intercept, my b value, is at negative a half right down here, okay? And then from there, I'll go down 3, right 2, down 3, right 2, and I will get that purple line. Now, you'll recall, solving by graphing, the solution is the point of intersection, so I go and read the point of intersection, and I can see that the solution is going to be at 3, negative 5. Remember that solutions are always written as coordinate pairs, unless you're doing a word problem. If you're doing some sort of a word problem, the solution has to be the answer to the question. But other than that, the solution is always coordinate pairs. So bracket 3, negative 5. Now, I'm going to walk you through the exact same question, except now we're going to go through the process of substitution. So what I do to do substitution, and I really want you to watch my work carefully, okay? This is really important that you communicate well. So really watch how I've set this up. I always set up substitution thinking about it in 2 columns. So I've got one equation for one column and the other equation for the other column. Now, the first step is going to be, I want to isolate one variable. So either in the first guy here, I make this say x equals, or I make this say y equals. Or in the second guy, I make this say x equals, or I make this say y equals. Okay? Doesn't matter which one I do, which means there are 4 different ways I could start this. Of all those 4 ways, in this particular example, one of those is way easier than the other, and it would be to make this guy the one that I want to isolate. The reason that guy's easier for this one is because there's no number on the y, right? If there's a number on your variable, you have to divide by that, whatever that coefficient is. Well, think that through. Often when you have to divide everything by that coefficient, you have to introduce fractions. So anytime we can avoid fractions as long as possible in a question, that's probably better. Okay, so I'm going to take a look at that y, and I'm going to say, okay, I want to isolate for that y, which means that 4x has to come over here. So that will be y equals negative 4x plus 7. Okay, now think this through. I'm saying that y, sorry, I'm just trying to change colors at the same time here. I'm saying that y is the same thing as negative 4x plus 7. That's the same as saying Ivan is the same as 2 grandmas and an acrobat, okay? Anytime I see y, I could now replace it with negative 4x plus 7. So what I'm going to do is I'm going to take a look at this other equation, and I'm going to say, hey, this says 2 times y. So instead of saying 2 times y, I can say 2 times negative 4x plus 7. Okay, remember I said how important communication is. So what I'm going to do is I'm going to arrow over to say I'm going to take this information and I'm going to go over to the other equation, and I'm going to use that information in the other equation. So I arrowed over, and now I'm going to write the other equation, but where I saw y, I'm going to replace it with a negative 4x plus 7. Okay, now the nice thing about that is now I'm looking at an equation over here that just has x there. So I can actually solve for x. I'll distribute the 2. Okay, so that will give me 3x minus 8x and plus 14. Now, I can combine the 3x and the negative 8x, so that'll be negative 5x. I'll also subtract 14 from both sides. So I get negative 5x equals negative 15. And then to get x by itself, I divide by negative 5, so that'll give me x equals 3. Okay, now that I know x is 3, I can arrow back to where I had left off, plug in that value for x, and actually get the number for y, right? I had left off with an expression for y, but now that I know that x is 3, I can get the actual number for y. So take note again, I'm drawing an arrow back to say, okay, I'm gonna take this information and go back to where I was, plug that in for x, and then that's gonna give me negative 12 plus 7, which is negative 5, and then my solution is still gonna be that coordinate pair. Even though I'm not graphing anymore, my solution is a coordinate pair unless it's a word problem where I'm answering the question, okay? So the solution is bracket 3 comma negative 5. So for those of you who like to have steps written down, I've written down steps for you. What we're gonna do is we solve either equation for x or for y, and really it's all about whatever's easiest there, okay? Then we substitute the expression in place of the variable in the other equation, and that's where I use those arrows to go over, okay? I'm really big on that because I need you to communicate. It's a problem for a math teacher when we are trying to find your work, okay? Math teachers should never have to find or figure out what you're doing. You should be able to communicate it clearly. So that's why I'm really emphasizing, make sure that your work is as clear and as concise as possible. Solve for that remaining variable. Oh, sorry, I didn't mean to go ahead so quick. Solve for that remaining variable and then substitute the answer that you got back into where you had left off. And then if desired or required, you can check your solution in both the original equations. So remember that for that verification, you would plug your x and y into both equations and then just work on the left side, just work on the right side, bring it down until they both end up being the same number, okay? All right, so we're gonna practice this together a few times, make sure everybody's super comfortable. Here's the next one we're gonna do, x plus y equals 8, 2x minus 4y equals 10. Again, just make sure you're starting off with 2 different columns, okay? I need to isolate for one of them. Now I could isolate for the x here, or I could isolate for the y here. I would probably go with this equation, but whether I choose to isolate for x or whether I choose to isolate for y really doesn't matter. I happen to have chosen to isolate for x in this guy, so I just took my y, I brought my y over to the other side, and now I've got x equals negative y plus 8, okay? Now remember, that's a statement. I know now that x is the same thing as negative y plus 8, which means anytime I see x, I could replace it with negative y plus 8, okay? So I'm gonna arrow over to the other guy, and I'm gonna say, okay, I'm gonna write that other guy, but when I see x, I'm gonna replace it with negative y plus 8. So now I'm gonna solve for y in this equation. The first thing I have to do is get rid of the brackets. So I'm gonna distribute that 2 times neg y is negative 2y, and 2 times 8 is 16, okay? Now I'll combine like terms, so I've got negative 2y and negative 4y, that will give me negative 6y, and then I'm gonna subtract 16 from both sides, so that gives me negative 6y equals negative 6. Okay, now to get y, I divide by negative 6, so y is 1. Now that I know y is 1, I'm gonna arrow back to where I had left off. I'm gonna plug that back in for my y. So this said negative y, and I replaced my y with 1. So now it says negative 1 plus 8. Negative 1 plus 8 is 7, so I know that x is 7. And then I conclude, my conclusion is always a coordinate pair unless I'm doing a word problem. Okay, so the solution is bracket 7 comma 1. Okay? Every time we do one of these, it's gonna feel a little better, okay? But I really want you to get comfortable with the algebraic process here. Okay, let's take that same system and we're just gonna verify the 7 comma 1. So remember, when we verify, we're gonna plug in the value for x and the value for y and see if we get a true statement. So I plugged in 7, I plugged in 1, 7 plus 1 is 8, so I've got 8 equals 8, which is awesome, that works. Remember though that verifying it with one equation doesn't verify the solution. It only shows that it works with one equation. You always have to do it with both equations. So I'm gonna go over to the other guy. I'm gonna plug 7 in for x and 1 in for y. 2 times 7 is 14 and minus 4, so then 14 minus 4 is 10. So it does work for both of them. I have verified the solution, okay? All right, let's try the next guy. So again, I want to either get x by itself or get y by itself, okay? I'm gonna probably deal with this first equation, and I'm probably gonna get x by itself. The reason I'm gonna choose to get x by itself is I see I could divide everything by 3 to get x by itself, and I see that that's friendly. If I was gonna get y by itself in this equation, I'd have to divide everything by 6, and I'm gonna actually end up with a fraction. So remember, whenever we can avoid fractions, usually that's easier on us. It helps us to think a little more clear. So here I go getting x by itself. I needed to get rid of the negative 6y, so I brought that over. Essentially, I added 6y to both sides. Now I'll divide everything by 3, and that'll give me x equals 2y plus 6. Okay? I have a statement that says x is the same as 2y plus 6. So anytime I see an x, I could replace it with 2y plus 6. Okay, that means I'm ready to go to the other equation, and I'm ready to write that other equation, but instead of x, I replace it. Remember, when you replace, you always have to replace with brackets as well. Otherwise, you're going to forget to distribute that 6. Okay, so I've taken my x, I've replaced it with the 2y plus 6, and now I have a one variable equation that I have the ability to solve. So I need to get rid of the brackets first. So I'm going to multiply by 6. That's going to give me 12y and 36. And then minus 12y equals 12. Now, something fun happens here. 12y minus 12y is nothing. It's gone. It's 0. Do you agree? Okay, so I get a statement that reads 36 equals 12. Now, this is an important communication point, okay? If all your variables suddenly disappear in the middle of this, then that kind of branches you into one of two different camps. That's what's going to tell you algebraically that either your system has no solutions or your system has infinite solutions. You'll recall when we were talking about graphing, we had, as long as the slopes were as long as the slopes were different, we'd have one solution, right? But if the slopes were the same and the y-intercepts were different, that was parallel lines, and there was no solution because there's no intersection point for parallel lines. And if the slopes are the same and the y-intercepts were same, that meant those lines were overlapping, and there'd be infinite solutions. So how do we tell that when we're doing it algebraically? Well, you want to look at this statement and you want to ask yourself, is this statement true? 36 does not equal 12. That is not a true statement. So that means there are no solutions. If this said 36 equals 36, or if it said 0 equals 0, or some sort of true statement like that, that would have told you it was infinite. Okay, so there are no solutions, the lines are parallel. And in your conclusion to this, whether it's algebraically or graphically, in your conclusion, I want to see both of those as part of your conclusion. I want to see the phrase no solution, and I want you to connect with me to say that that means the lines are parallel. I want both of those statements, okay? So just to summarize what just happened, note, when solving algebraically and both variables disappear, if you ever get a true statement like 0 equals 0, this indicates an infinite number of solutions, and it tells you that the lines are overlapping. But if you ever get a non-true statement like 0 equals 5, like the one we just got, 36 equals 12 for us, that indicates that there's no solution and the lines are parallel. Okay? All right. Now we have big scary fractions, and everybody gets all kerfuffly about fractions. Okay, well, you can deal with the fractions if you want. You can solve this whole thing using fractions if you're comfortable with that. I probably would do that because I like fractions. Fractions don't bother me. But I'm doing this to help you, so let's get rid of the fractions. Let's say that fractions scare us all and we just don't want to deal with fractions. So I'm going to take a look at this guy here and I'm going to say, okay, I could multiply everything by 3, right? That would get rid of the division of 3 for me. So I could go ahead and multiply everything by 3 and then I wouldn't have to deal with fractions. Now, that's okay to do if you want to play that game so that you don't have to deal with fractions for a little bit at least. Totally okay. Just make sure you do it right, okay? What happens is lots of kids look at this and they say, okay, I need to multiply by 3, and they do this one beautifully. They go 1/3 times 3, so that's just gonna give me x. And they even do this y beautifully, and they say, okay, y times 3 is 3y. But then often kids forget about that second term on that side, every term has to get multiplied by 3. So if you're going to do that, don't forget that the 5 also has to get multiplied by 3. Okay, and that's where that 15 is coming from. Okay, now the way this worked, this also actually isolated x for me as well. I have x all by itself. I have a statement that says x is the same as 3y plus 15. And so anytime I see anytime I see an x, I can replace it with 3y plus 15. So I'm going to arrow over to the other guy, and I've replaced my x with 3y plus 15. Okay, and then I still have the subtract 5y and the equals 13. Now again, we have fractions, so again, maybe you don't want to deal with the fractions. If I don't want to deal with the fractions, I have to get rid of a division of 5, so I'll multiply everything by 5. Okay, when I do that, I end up with 15y. Okay, that's 3y times 5. 15 times 5 is 75. Remember, I'm doing it to every term I see. Negative y over 5 times 5 just gave me the negative y. And the 13 times 5 gives me the 65. So now I don't have to deal with fractions for another little bit. I can play that denial game for a bit. Okay, so I've got 15y minus y. That'll give me 14y. And then I have to subtract 75 from both sides as well. So that's going to give me 14y equals negative 10. Now, to get y by itself, I have to divide by 14. Now I do have to deal with the fraction, okay? Because my answer is a fraction. It's going to be negative 10 over 14. So I don't want a decimal there, okay? Never give me a decimal unless you're talking about money. So negative 10 over 14 would reduce, though. And so my final answer for y would be negative 5 over 7, okay? Now that I know y is negative 5 over 7, I'm going to arrow back to where I had left off. Whoops. I'm going to arrow back to where I had left off, and we're going to figure this out together. So 3 is like 3 over 1. When I'm multiplying, I multiply the tops, multiply the bottoms. So that'll be negative 15 over 7. And then I'm going to add 15 to that, okay? So if I want a common denominator there to add, 15 times 7 is 105. So I'm looking at negative 15 over 7 plus 105 over 7. So 105 minus 15 is 90. So my final answer there would be 90 over 7. Okay, and again, if you don't want to do that in your head, that's totally fine. Grab your calculator and let your calculator help you with that. Okay, I'm not taking that away from you. But I do want you, as we go through some of these conversations together, I want you to try it in your head because that really helps your mathematical understanding. Okay, so I have my solution, but I'm going to write it as a coordinate point. The solution is 90 over 7, comma, negative 5 over 7. So now what we want to do is end with some word problems, okay? So the difference here is not much, except that you have to build the system, okay? And we've already done that, right? We've been doing that since our very beginning lesson. Remember, when you go to build a system, you have to start with a legend, and then you have to build your system, solve your system, and then super important, you have to actually answer the question on this guy. So now that we're into word problems, your answer is not going to be a coordinate pair, but rather it's going to be the answer to the question, okay? So the front of a gingerbread house is a rectangle. The length of the rectangle is 5 centimeters less than triple its width. If its perimeter is 14 centimeters, determine the dimensions of the rectangle, okay? So we got to build a system, so we got to start with the legend. What two things are we talking about? We're talking about length and we're talking about width. So that's where my legend's going to come from. I'm going to let x be length and y be width. So now I have to come up with some equations. Well, remember, we probably had this talk in a previous lesson. This word is, okay, that word is always your equal sign. So anything to the left of is to the left of your equal sign. So it says the length is, well, the length is x, okay? So now I've got x equals 5 less than triple its width. Well, that's what's going to go on the right side. So 5 less than triple its width. Triple its width would be 3y. 5 less than that would be 3y minus 5. So one equation is going to be x equals 3y minus 5. Now, the other equation involves perimeter. Just remember, with perimeter, you're talking about a rectangle. Okay, so if I have a rectangle and I'm looking at the distance around it, I've got x and y. So that'll be 2x plus 2y equals whatever the perimeter is. In this case, the perimeter is 14. So I have 2x plus 2y equals 14, and I've got x equals 3y minus 5. I've now created my legend, and I've built my system. Okay, now I have to solve my system. We're solving by elimination, or sorry, by substitution today. I really want to start elimination, eh? We're solving by substitution today. And I already have one isolated. If you look at this guy here, x is already by itself. So I already have a statement, the way this got built, that says x is the same as 3x minus 5. Okay, so I'm going to arrow over to the other equation, and wherever I see x, I'm going to use brackets and replace that x with 3y minus 5. So now over here, I need to solve for y. So I'm going to distribute the 2. 2 times 3y is 6y minus 10, 2 times negative 5. Okay, I'll combine like terms here. So I've got 6y plus 2y will give me 8y. I need to get rid of a negative 10, so I'll add 10 to both sides. That's where the 24 is coming from. Okay, and then to get y by itself, I'll have to divide both sides by 8. So y is 3. Now I'm going to take that information. I'm going to go back to my original equation that I had left off on, plug that information in for y so that I can solve for x. So that's going to give me x is 4, 9 minus 5. Okay, now remember, the solution to this is not a coordinate point anymore because it's a word problem. So you have to actually answer the question. The question asked you for dimensions, so we say, or we conclude, the dimensions of the rectangle are 4 centimeters by 3 centimeters. Okay. All right, a collection of 22 coins consists of dimes and quarters, worth a total of 340. How many dimes and how many quarters are there? So here we go, we got to start with the legend. Well, what are we talking about? We're talking about the number of dimes and the number of quarters. So that's where my legend is going to come from. I'm going to call x the number of dimes, and I'm going to call y the number of quarters. Now, my first equation is the number of coins I have. I have 22 coins, so I know that x plus y has to equal 22. Okay, now the second equation deals with the money, deals with the value. Okay, so there's two different ways I can do this. You just have to be careful that you don't switch your units. Okay, so I'm going to look at this and say, okay, a dime is worth 10 cents. So I'm going to call the amount of money I get from dimes 10x. I take the amount of dimes I have, multiply it by 10, and that would give me the amount of money I have for dimes. Okay, then for the amount of quarter money, I'm going to go 25 times y because the quarters are 25 cents. Here's where you got to be careful. I want you to notice that I've talked in cents. So I can't say that that equals $3.40. I have to say that that equals 340 cents. Okay, so my equation there will be 10x plus 25y equals 340. Now, if you had wanted to do it all in dollars, that's cool. Your equation would have been 0.1x plus 0.25y equals 3.4. That would have been fine as well. Okay? All right, so I built my system. Now I want to solve by elimination. Sorry, I did it again. I want to solve by substitution. You guys are going to be like so excited about elimination. So I need to isolate for either x or y. Probably I want to work on that first equation, and I chose to isolate for x. So I just took my y and I brought it over there. So x equals negative y plus 22. I'm going to take that information and I'm going to plug it into the other equation. Okay, so where I saw x, I substituted it with my negative y plus 22. Now I need to solve for y. So I'll distribute the 10 into both of those terms. That's going to give me negative 10y plus 220 plus 25y equals 340. Combine like terms, so that's going to give me 15y. And I'll have to subtract 220 from both sides. And then I'll have to divide by 15. Okay, that gives me y equals 8. Now this is a great time to stop and just have a quick conversation about when you're doing these, you always want to think about the check and balances that are in place. You always want to think about the context of the question. If you got here and you got -2 as an answer, well, you can't have -2 quarters, so something went wrong somewhere. Or say you got 6.3 as an answer. You can't have 0.3 of a quarter. You either have a quarter or you don't have a quarter. So a lot of times with some of these word problems, even halfway through, you can start asking yourself, does this make sense in the context of the question? So we're feeling okay right now. We got a whole number. Things are good so far. So now that I know that y is 8, I'm going to plug that back into the original equation where I had left off. and I'm going to solve for x, which is going to give me 14. Now, remember, you also have to answer the question, there were 14 dimes and 8 quarters. Okay? All right. Last word problem that we'll talk about today. Alexia invests $1,800, part at an annual interest rate of 3.5% and the rest at an annual interest rate of 4.5%. After 1 year, the total interest was $73. How much did she put in the investment? So again, we got to build our system first. In order to build our system, we have to start with a legend. So what are we talking about? Well, we're talking about the amount of money I put in one investment versus the amount of money I put in the other investment. So that's where my X and Y are going to come from. I'm going to call X the amount in the 3.5% bond, and I'm going to call Y the amount in the 4.5% bond. Okay, so altogether, I invested $1,800. So my first equation would be X plus Y equals 1,800. That's the total of what I invested. The second equation comes with the interest. Now, in order to figure out how much money I earn on interest, what I'd have to do is I'd have to take the amount I invest and I'd have to multiply by the interest rate as a decimal. Okay, you never use percentages in that. So 3.5%, for instance, as a decimal would be 0.035. I take my percentage and I divide by 100. Now, how much did I put into that bond? Well, I put X into that bond. I don't know, that's my unknown. So the amount I earn in interest would be 0.035X. The amount I earn in interest on the second bond would be 0.045Y. And then the total amount of interest is 73. So that equation becomes 0.035X plus 0.045Y equals 73. So I've established my legend, I built my system, now I need to solve my system. So I'm going to isolate for one of these guys. I chose to isolate for Y in the first equation. So that means I just brought my X over to the other side. I'm going to take this knowledge that Y is the same as negative X plus 1,800, and I'm going to put it into the other equation. I'm going to substitute this Y right here with my negative X plus 1,800. Okay, and now I'll have to distribute the 0.045 to both of the negative X and the 1,800. I'm going to have to combine like terms. So this is going to give me negative 0.15X. I'll subtract 81 from both sides. Sorry, negative 0.01. Sorry, that gives me negative 0.01X. And I subtract 81 from both sides, so that's where the negative 8 comes from. Then I'll have to divide both sides by negative 0.01. That's going to give me 800. Okay, so then I plug that back into one of the original equations and get what Y would be, and Y is 1,000. Now I need to conclude. The question said, how much did she put in each investment? So I say Alexa invested $800 in the 3.5% investment and $1,000 in the 4.5% investment. It is important that you connect which number goes with which item. Okay, you can't just say she invested $800 and $1,000, because then I'm left not being sure if you understand which investment was which. Okay, so make sure your conclusion tells me you understand that number is my X and X represented this, and that number is my Y and Y represented this. Okay, good. Okay, so to solve a system using substitution, we must always isolate for one variable. Choose the variable that is easiest to isolate, although it doesn't actually matter which one you choose. We verify our solution by substituting the values into our original equation, or we could verify by graphing. Okay, if I ask you to verify on a test though, I'm expecting you to algebraically do that. Solving algebraically will give us the exact solutions, whereas solving graphically, graphic solutions that aren't on lattice points, your graphing calculator will only give you decimals or even approximate solutions when we get into more complicated answers. So solving algebraically is always the better way. Now, that being said, I do want to make a point that on a quiz or on a test, we will force you to solve a particular way. Okay, because part of the grade 10 curriculum is that you understand all three of these methods. So you understand how to solve by graphing, how to solve by substitution, and how to solve by elimination. So if I ask you a question and I say solve this by substitution and you choose to solve it by graphing, your answer is worth nothing because it's the process that you're getting marked on. Okay, so make sure in these questions you read the question very carefully and that you are actually solving using the process you've been asked to do. And we will force all of them on you. There will be a question where it says solve by graphing, there will be a question that says solve by substitution, and there will be a question that says solve by elimination, and you won't get value for any of it if you don't use the process you were asked for. Okay, so that's something to keep in mind. Okay, so I posted some work for you to practice. Have lots of fun with it. I know you'll have lots of fun with it. And if you have any questions, make sure you check in with me. Okay, we'll see you on the next lesson for elimination.